Hello students, welcome back to my channel JP Physics. In last lecture, we have discussed about the 4 derivations from the chapter oscillation. In this lecture, we will discuss another last derivation from the chapter oscillation, that is time period of simple pendulum. Another 2 derivations we will see in this lecture from superposition of wave, that is the amplitude of resultant wave due to the superposition of 2 waves, and another derivation, that is equation or expression for superposition of wave. So these 3 derivations we will do in this lecture. These 3 derivations are very important. They are frequently asked in your exam for 3 marks. Okay, so let us see first derivation, that is time period of simple pendulum. So to do this derivation, first you have to know what is mean by simple pendulum. What is the definition of simple pendulum? Because in this question they will ask define simple pendulum and derive the expression for time period of simple pendulum. So first you have to know what is the definition of simple pendulum. So what is the mean by simple pendulum? Simple pendulum is the assembly in which a heavy particle is suspended by a inextensible, massless and flexible string. Inextensible, massless and flexible string. That heavy particle is suspended from or by that string. So to derive the derivation for this time period of simple pendulum, first we will consider the diagram. See, this is simple pendulum which having length L and it is oscillating about its mean position, okay, by making some angle theta with the vertical one. Okay, now this mass, if the length of this pendulum is L, then tension in the string will act in upward direction or away from this mass. There are 2 forces acting on this mass, that is weight force mg, which is in a downward direction, and another force, that is tension in the string. Now this tension in the string will get balanced by the component of this weight force mg, because there is no any component, no any force to balance this tension. Okay, so we will split this weight force mg into its components, and that component will be this component and another is this component. Now if this angle is theta, this angle will be also theta, that is corresponding angle. These 2 are parallel one, therefore these 2 will be corresponding angles. Therefore if this is theta, this will be also theta. So the component near to theta, that will be mg cos of theta. So this component will be mg cos of theta and this component will be mg sin theta, right one? Mg sin theta. Now this is the path along which that pendulum is oscillating and this will be tangent to this, right one? Okay, this path means this component mg sin theta is providing the necessary restoring force. Restoring force is responsible to bring that simple pendulum to its equilibrium position, or you can say towards its mean position. So this restoring force restores the simple pendulum to its mean position. Therefore this mg sin theta is providing the necessary restoring force. So what I can write? I can write F is equal to minus mg sin theta. Why this minus sin theta is here? See, this force and the displacement are in opposite direction, and to show that opposite direction we have to use the negative sign here. Now here theta is very small. Theta is very small. Therefore sin theta will be approximately equal to theta. So this formula will become F is equal to minus mg theta. Now if I consider the displacement of this bob or of this pendulum from its mean position to extreme position through the displacement x, if I consider this displacement from mean position to extreme position as x, then I can write by using this geometry. See, theta is the angle. If I consider this as a circular path, अगर मैंने ये पूरा path circular है ऐसा consider किया, तो this will be the center. If I take this point as a O, this will be center and this is the central angle, and this will be the arc of the circle. This will be the arc of the circle. Means if I give the name as A and B, A as a mean position, B as a extreme position. Then this AB will be displacement of the simple pendulum. So by the geometry, what I can write, theta is equal to x upon L. अगर हम थीटा की वैल्यू इस एक्सप्रेशन में पुट कर दे तो F इज इक्वल टू क्या आएगा, F इज इक्वल टू माइनस mg x अपॉन L, राइट वन. F is equal to minus mg x upon L. Take this equation as equation number 1. But in this expression, what we have to find out? We have to find out that is time period of simple pendulum. हमें क्या find out करना है? Time period of simple pendulum. Then what is the formula for time period? Time period is nothing but 2 pi upon omega. And we know another formula for this as 2 pi divided by under root acceleration per unit displacement. Acceleration per unit displacement. You know this formula from this chapter. Oscillation, you have studied already this formula. How? See, I will give you explanation. See, T is equal to 2 pi upon omega, right one? But in differential equation, we have put up one constant for k upon m as a omega square, that is k is equal to m omega square. So what will be the value for this omega? It is 2 pi by t, right one, square of that. I want this time period, right one, I want this value of time period. So I will take this t square here and this 2 pi square upon k upon m will be in the denominator. Then what is this k upon m? What is this k? K is nothing but the spring constant. We have seen that F is equal to minus kx, or you can say F is equal to kx. If I write k is equal to F upon x, then what will be this quantity? This is nothing but force per unit displacement. K is what? Force per unit displacement. If it is force per unit displacement, then this is force per unit displacement upon mass. And we know that F is equal to mass into acceleration. And acceleration will be force upon mass. Force upon mass is nothing but the acceleration. Then force per unit displacement upon mass will be acceleration per unit displacement. अगर ये k force per unit displacement है तो ये force ही तो है. ये क्या है? फोर्स है. फोर्स पर यूनिट डिस्प्लेसमेंट. फॉर यूनिट डिस्प्लेसमेंट जो भी फोर्स होगा उसको हम क्या कहेंगे? के. दैट इज फोर्स पर यूनिट डिस्प्लेसमेंट. एंड फोर्स अपॉन मास, इट इज नथिंग बट द एक्सेलरेशन. अगर फोर्स अपॉन मास या एक्सेलरेशन है तो फोर्स पर यूनिट डिस्प्लेसमेंट पर unit mass means divided by mass, that will be acceleration per unit displacement. Acceleration per unit displacement. So we have to find out this quantity, acceleration per unit displacement. How we can find out? See, this is the force minus mgx upon L. We know the another formula for force, that is F is equal to ma, mass into acceleration. Right one. So I can equate this mass into acceleration to this force, that is ma is equal to minus mgx upon L. Get cancel. If I take this x towards left side, then it will be a upon x is equal to minus g upon n, right one? Minus g upon n. A upon x means what? Acceleration per unit displacement. Acceleration per unit displacement means if I put this value in this expression, I will get the expression for time period. Therefore, T is equal to 2 pi upon, what is this acceleration per unit displacement? It is nothing but minus g upon L, but we will take only magnitude. We will take only magnitude, g upon L, only magnitude. हम क्या लेंगे? only magnitude. We are not going to consider the sign. This sign is only to denote the direction of the displacement and the force are in opposite direction. So we will consider only the magnitude. Therefore here there will be g upon L. T is equal to 2 pi upon under root G upon L. If I make it cross multiply, then this formula will becomes 2 pi under root L by G, and this is the required expression for time period. This is the required expression for time period, that is T is equal to 2 pi under root L by G. You understood what you have to do for this expression? You have to draw this diagram. If they ask for definition, you have to write the definition first. अगर उन्होंने definition पूछी है तो आपको definition पहले लिखनी है. Definition के बाद इस diagram के लिए भी mark reserve रहेंगे, because you are going to denote the components of this weight force mg. mg के components दिखाने हैं. जो component रिस्टोरिंग फोर्स प्रोवाइड कर रहा है उसको आपको इक्वेट करना है. F is equal to minus mg sin theta. Minus sign shows that displacement and the force are in opposite direction. यहाँ theta बहुत ही small है, therefore we can equate sin theta is approximately equal to theta. Equation will becomes F is equal to minus mg theta. But if you observe the geometry of the diagram, geometry of the figure, then you can understand theta is nothing but AB upon radius, that is arc upon radius. Therefore, theta is equal to x upon L. X is the displacement of this bob or this simple pendulum from mean position to extreme position, that is x. Therefore, theta is equal to x upon L. F is equal to minus mg. If we put this value of theta here, it will be minus mg x upon L. We'll take this equation as equation number 1. Now what we have to find out? We have to find out the time period, and we know the formula for time period as T is equal to 2 pi upon omega. इसी expression को हम कैसे लिख सकते हैं? 2 pi upon under root acceleration per unit displacement. How this formula becomes, I have explained here. Okay, from that differential equation and formula for force, that is F is equal to kx. Okay, so what is the formula for force? Force is equal to mass into acceleration. Means हमें अभी इस acceleration per unit displacement find out करना है, तो हमें acceleration की term तो आनी चाहिए उधर, correct? और we know the formula for mechanical force, that is F is equal to mass into acceleration, and this force will be same. Therefore, mass into acceleration is equal to minus mgx upon L. Mm get cancelled. Remaining part will be A is equal to minus gx upon L. If I take this x towards left side, it will get divided, and this term will becomes acceleration per unit displacement, and we have to put up the value of this A upon x in this expression. That value is minus g upon L. Put this value in this expression, but by only magnitude. आपको सिर्फ magnitude लिखनी है. Don't take minus sign. Okay, we are going to write only magnitude here. So T is equal to 2 pi upon under root G upon L. If we make the cross multiplication, that formula will become T is equal to 2 pi under root L by G. Actually, you know this formula from 11th standard, but derivation is now only. Okay, so T is equal to 2 pi under root L upon G. This is the formula for time period. You can take the screenshot also. From this screenshot, you will get the idea for that acceleration per unit displacement. Okay, so we will see next derivation, that is amplitude of the resultant wave of superposition of two waves. अब हमें amplitude निकालनी है. There will be question like derive the expression for amplitude of resultant wave due to superposition of two waves. जब दो वेव सुपरइम्पोज हो जाएंगी तो उनकी रिजल्टेंट एम्पलीट्यूड क्या होगी, उसका एक्सप्रेशन अभी हमें निकालना है. राइट वन, दैट इज एक्सप्रेशन फॉर एम्पलीट्यूड ऑफ रिजल्टेंट वेव ड्यू टू द सुपरपोजिशन ऑफ टू वेव्स. Superposition of two waves of amplitude of resultant wave produced due to superposition of two waves. Okay, For this derivation, we have to consider the two waves with different amplitudes and some phase difference between them. So I will consider one wave as a y1 is equal to a1 sine omega t, and another wave as a y2 a2 sine omega t plus phi. Here there is a phase difference between these two waves as a phi. I'm going to consider these two waves, and if these two waves superimpose with each other, then what will be the amplitude of resultant wave we have to find out. So for that superposition, what I can write, y is equal to y1 plus y2. See, theory will be only this. Let us consider two waves having different amplitude and some phase difference between them. Angular frequency is same of that two waves. Therefore, that wave will be y1 is equal to a1 sine omega t, y2 is equal to a2 sine of omega t plus phi. Now all the part will be mathematics. Okay, so इसके आगे का सारा पार्ट मैथमेटिक्स पार्ट में होगा, means there will be calculation only. Okay, so y we have to add this a1 sine omega t plus a2 sine omega t plus phi. Now split this term. What will it becomes? a1 sine omega t plus a2 in bracket sine omega t cos of phi plus cos omega t sine of phi. You know this formula. Sine of a plus b. Sine a cos b, cos plus cos a sine b. You have to know this identity. Okay. Now a1 sine omega t plus a2 sine omega t cos of phi plus a2 cos omega t sine of phi. Now if you observe this, here there is a common term, that is sine omega t. Take it out. What will expression remain? See, a1 sine omega a1 plus a2 cos phi into sine omega t plus a2 cos omega t sine phi. I will write this term as this. I will write this sine phi first and then cos omega t. Okay, there will be no change. There is a multiplication sign. a2 sine phi cos omega t. Okay, now we have to make the substitution here. Okay, what will be that substitution? a1 plus a2 cos of phi, I am going to substitute as a cos of theta. And here in place of a2 sine of phi, I will put a sine of theta. See, in last expression also, from that oscillation, we have put up that value in terms of r cos delta and r sine delta. Where the cos phi is there, we have to put as a cos theta. If there is a sin phi, we are going to put sin theta. जहां cos phi रहेगा वहां substitution cos theta के फॉर्म में होगा, जहां sin phi रहेगा वहां substitution sin theta के फॉर्म होगा. Means let put a1 plus a2 cos of phi is equal to a cos of theta and a2 sin phi is equal to a sine of theta. If we put these values in this above expression, that is y is equal to a1 plus a2 cos phi into sine omega t plus a2 sine phi cos omega t, we will get the value as y is equal to, what will be y is equal to a1 plus a2 cos of phi. In place of that, I have to write a cos theta. So that will be a cos theta sine omega t. That sine omega t is common here, right one. And in place of a2 sine phi, I will put a sine theta plus a sine theta cos omega t as it is. Cos omega t as it is. Here, cos omega t. Then what is this? There is a common cos theta sine omega t. Sine theta cos omega t means it is nothing but sine of omega t plus theta. This is the expression for wave. See, but we have to find out the amplitude of the resultant wave. This is the expression for resultant wave of superposition of two waves. But we don't know this value of A here, resultant amplitude. That is amplitude of resultant wave of superposition of two waves. इन दो waves का हमने superposition किया. A1, A2, these are the separate amplitude of these different waves. But this is the resultant amplitude of these two waves, and we have to find out the value of this amplitude. So you are maybe you are remembering that in that case also, when we have put up the substitution as r cos delta and r sin delta, what we have done, we have made the square of these two equations and add them. If I take this equation as 1 and this equation as a 2, squaring and adding equation number 1 and 2, what we will get, let us see. If I square these terms, then a square cos square theta, square of this term as a square cos square theta plus a square sin square theta, right one, equal to a square cos square theta plus a square sin square theta is equal to square of this term a plus b whole square. What will be the square? C, a1 square, okay, plus 2a1 a2 cos of phi. See here, 2a1 a2 cos of phi plus a2 square cos square phi plus a2 square cos square phi plus square of this term, that is a2 square sin square phi. a2 square sin square phi. Only you have to make the square. आपको इन दो इक्वेशंस का स्क्वायर करना है. लेफ्ट का स्क्वायर लेफ्ट में ऐड करेंगे, राइट का स्क्वायर राइट में ऐड करेंगे. तो राइट का स्क्वायर क्या हुआ? ए स्क्वायर कॉस स्क्वायर थीटा प्लस ए स्क्वायर साइन स्क्वायर थीटा इज इक्वल टू a1 स्क्वायर प्लस 2a1 a2 cos square phi plus a2 square cos square phi, right one? And square of this term will be a2 square sin square phi. Now this a square is common here. In bracket there will be only cos square theta plus sin square theta. And what is meant by a square cos square theta plus sin square theta? It is the identity, it having value 1. Therefore only the term will remain, that is a square. A square is common, cos square theta plus sin square theta, that is equal to 1. Now a1 square will be as it is, 2a1 a2 will be also as it is, cos of phi, and the last term, see here, a2 square will be common and remaining will be cos square phi plus sin square phi. Then that will be also 1. So only remaining part will be a2 square. Then what will be the resultant amplitude? A is equal to a1 square plus 2a1 a2 cos of phi plus a2 square, and this is the required value of resultant amplitude, or the amplitude of resultant wave produced due to superposition of two waves. For this expression you will get 3 marks. Here the important thing, you have to take the different amplitudes and some phase difference between the two waves, add them, make the calculation, you will get the resultant wave as a y is equal to a sine of omega t plus theta. But here we have to find out the amplitude, expression for amplitude of resultant wave. Then we have to find the value of a here. So for that substitution we have make here, we have to make the square of that substitution and add them. मीन्स इसका स्क्वायर कर दो, इसको ऐड करो. इन दो इक्वेशंस का अगर आप स्क्वायर करके ऐड करोगे तो आपको एक्सप्रेशन ये मिलेगा. अगर ए स्क्वायर को कॉमन निकालेंगे तो cos स्क्वायर थीटा प्लस sin स्क्वायर थीटा ब्रैकेट में रहेगा, विच इज द आइडेंटिटी इक्वल टू 1. That is a square is equal to, this term will be as it is, but here again a2 square is common. If we taken it out, then remaining part will be cos square phi plus sin square phi, again that will be equal to 1. Therefore only the term will be a2 square, and resultant amplitude will be under root a1 square plus 2a1 a2 cos of phi plus a2 square. And this is the required expression, or this is the required result for this question. You understood? See, if any doubt about this derivation or any previous derivation, you can ask me, comment me in the comment box. I will give the answer for that. Also, if you want any numerical to solve, if you have any doubt about the numericals, you can ask me. I will give the answer for that questions. Okay. So now we will do the third expression or third derivation, important derivation, that is expression for stationary wave. Okay. So let us do that. Expression for stationary wave. Expression for stationary wave. So what will be the expression for stationary wave? First you have to know what is mean by stationary wave. पहले आपको ये पता रहना चाहिए कि stationary wave होती क्या है. Stationary wave means the two identical waves traveling in an opposite direction when get superimposed, the formed wave or produced wave will be stationary wave. अगर दो identical waves opposite direction से move करेंगे, progress में रहेंगे, तो उनका जो resultant होगा वो क्या होगी? Stationary wave, or it is also called as a standing wave. For that we have to consider the two waves, but they are traveling in opposite direction. Means we have to consider two waves such that y1 is equal to a sine omega t. We have taken that omega t plus phi or all that. But here another form of that equation like a sine of 2 pi n t minus x upon lambda. X upon lambda. This is one format of that wave. You know this. 2 pi n t. 2 pi n means what? Omega t. Right one? 2 pi n means what? Omega. And 2 pi x upon lambda. What is 2 pi upon lambda? It is k. Okay, wave number, wave constant. 2 pi upon lambda. Therefore, it is one form of wave equation. So, y1 is equal to a sine 2 pi n t minus x upon lambda. Another equation we will take as a sine 2 pi n t plus x upon lambda. Plus x upon lambda. See, we have to consider the two waves which are traveling in opposite direction. Means, if I consider here minus, I have to take here plus. So, that will be propagating in opposite direction. So, now we have to calculate or we have to derive the expression for resultant of these waves. And that resultant will be equation for stationary wave. इन दोनों का resultant expression जो होगा, इन दोनों की resultant wave जो होगी, इनका superposition होने के बाद, that will be the stationary wave. So we have to add again them. So y is equal to y1 plus y2. Right one. Now y is equal to this a and a is common. Therefore I will take it outside. In bracket there will be sine of 2 pi n t minus x upon lambda plus sine of 2 pi n t plus x upon lambda. Right one. This is one identity, sine A plus sine B. What is the formula for sine A plus sine B? It is nothing but, or you can say sine C plus sine D. Right one. What is that formula? 2 sine A plus B upon 2 into cos of A minus B upon 2. Right one? 2 sine of A plus B upon 2 into cos of A minus B upon 2. So, one time, that is in sine, we have to make the addition. When cos term is there, we have to subtract them. So, we will use this identity, and what will be the expression? Y is equal to A will be as it is. This 2 I will take out. Therefore, 2A will be there. And now, sine of 2 pi n t minus x upon lambda and 2 pi n t plus x upon lambda. So, we have to add this 2 divided by 2. Then what will be the addition? See, 2 pi n t minus 2 pi x upon lambda plus this term 2 pi n t plus x upon lambda divided by 2. Right one. This will be sine of, I will write here, y is equal to 2a sine of in bracket. Okay, this will be the term into cos of. There will be subtraction now. From this we have to subtract this one. What will become? See, 2 pi nt plus means minus x upon lambda. Okay, 2 pi x upon lambda. 2 pi x upon lambda. This 2 pi will get multiplied here. 2 pi nt minus 2 pi x upon lambda. Then minus. This term will become minus, that is 2 pi nt minus plus, that will be again minus 2 pi x upon lambda divided by 2. So, what will happen? See, here 2 pi nt, here 2 pi nt, these two terms are plus, but this is minus and this is plus. Here also 2 pi x upon lambda. Therefore, this minus and plus, these two terms will get cancelled, and what will remain here? It will be 4 pi nt upon 2. Right one. And here in this case, 2 pi nt is plus and this 2 pi nt is minus. Therefore, 2 pi nt will get cancelled. And what will remain here? That is minus 4 pi x upon 2 lambda. So, y is equal to 2a in bracket sine of. Here, I will write here directly 4 pi nt upon 2 into cos of. What will be the value here? Minus 4 pi x upon this lambda will in the denominator, and this is 2 lambda. Okay, cos of minus 4 pi x upon lambda. This lambda will come in the denominator. Therefore, here there will be 2 lambda. Now, 2 2s are 4 here, and here also 2 2s are 4. Then what will be the term remaining? Y is equal to 2a sine of, see, 2a sine of 2 pi nt only, 2 pi nt only, and here cos of minus 2 pi x upon lambda, cos of minus 2 pi x upon lambda. I will rearrange the terms like 2a cos of minus 2 pi x upon lambda into sine of 2 pi nt. Understood? See, I have taken this term towards left and this towards right. There will be no any change. Multiplication is there. Now, cos of minus theta. Cos of minus theta is nothing but cos of theta. Right one. So, I can neglect this sign, or if I remove this sign, there will be no any change. So, I will write y is equal to 2a cos of 2 pi x upon lambda into sine of 2 pi nt. In place of this 2 pi nt, what I can write? Omega. 2 pi n is nothing but omega. Therefore, I will write sine omega t. Now, this will be the new amplitude or amplitude of that new wave, stationary wave formed due to superposition of these two progressive waves traveling in a opposite direction. Means this is the amplitude of that resultant wave, and I will put that value for this amplitude as y is equal to, see, put 2a cos of 2 pi x upon lambda. Let's put it as a r, resultant amplitude of the new wave formed due to the superposition of these two waves. Therefore, equation will becomes y is equal to r sine of omega t. This is the expression for resultant stationary wave. Y is equal to r sine omega t. You can put the value as a also here, but we have used here a resultant, that is 2a. Therefore, I have used the new constant, that is r. This r is the amplitude of the stationary wave formed due to these two progressive waves which are in a progressing or propagating or traveling in a opposite direction, and due to that we get the resultant expression for stationary wave where r is the amplitude and it having value 2a cos of 2 pi x upon lambda. You understood this derivation? See, first we have to consider two progressive waves. Y1 is equal to a sine 2 pi nt minus x upon lambda, and y2 is equal to a sine 2 pi nt plus x upon lambda. Here first, these two things you have to remember. Here there will be minus sign, here there will be plus sign. And amplitude will be same, identical waves, but traveling in a opposite direction, means amplitude must be same. Therefore you have to take here AA, same amplitude. Don't take A1, A2. Okay, now we have to add them, make the addition, and during making the addition you have to remember this formula, that is sin A plus sin B is equal to 2 sin of A plus B upon 2 into cos of A minus B upon 2. That angle you have to make the addition and subtraction. Okay, if you do that things, if you do that mathematics, you will get the derivation like y is equal to 2a sine of 2 pi nt cos of minus 2 pi x upon lambda. Here also you have to remember one thing, that is cos of minus theta is equal to cos theta. Therefore, this cos of minus 2 pi x upon lambda will becomes cos of 2 pi x upon lambda. And if you compare the equations we know for the wave, that is y is equal to a sine omega t, means this is the expression for wave, sine omega t is that is it, but here this is the amplitude of the new wave. ये नया जो वेव फॉर्म हुआ, स्टेशनरी वेव जो फॉर्म हुई, उसकी एम्पलीट्यूड है due to the superposition of these two waves. So we will put the value for this amplitude as r, and resultant wave equation will be y is equal to r sine omega t. This is the required equation for stationary wave. You understood the expression? If you want to take the screenshot, you can. Okay. So these are the three derivations from that oscillation and two derivations from superposition of wave. There are another derivations from that superposition of wave. I will make that for you in next video. Okay. So for today we will stop here. If you like my lecture, if you understood this all derivations, please like, share and subscribe my channel. Also press the bell icon so that you will get the notification about the next video in which I will do the remaining derivations from superposition of wave. So thank you.